Hi everyone, today we are doing a lesson on greatest common factor. So the question we're going to ask ourselves is, how can we find the greatest common factor of two numbers? So first, what are common factors? Well, common factors are factors that are shared by two or more numbers. The greatest common factor is the greatest or biggest number of those common factors. One way that we can find the GCF, greatest common factor, is by making a list. So I can list all the factors of 24, all the factors of 40, and then I can go ahead and circle the common factors, the ones that they have in common. And then I see that the common factors are 1, 2, 4, and 8. Well, the greatest of these common factors is 8. So the GCF of 24 and 40 is 8 because it is the greatest, the biggest common factor. Then we have some practice problems here that you can go ahead and try. I'll go ahead and do one. And we're going to talk about this further on in the notes, but instead of listing out all the factors, I'm actually going to do prime factorization. So I'm going to make a factor tree. So here is 8. And I'm going to list two factors of 8, which are 2 and let's go with 4. All right, so 2 and 4. Now, I still have to branch out here because 2 is a composite number. Or sorry, 4 is a composite number. Well, 2 over here is prime. So since this one is done, it's not going to have any more branches, I'm going to circle it. And now for 4, I have 2 times 2. And these are both prime numbers. So I'm going to circle them. And I can see that the factors of 8, 2 by 2 by 2. So it's prime factorization of 8. And later on down here, we're going to do the same thing for 36 and see if they have any in common. So now let's do the prime factorization of 36. So I'm going to do 2 times 18. Now 2 is already prime, so we'll circle that in a bit. Here I have 2 by 9. And then I have, to finish off my list, 3 and 3. All right, so these are all prime. So I have these ones right here. And my prime factorization of 36, well, I have 2 times another 2 here times 3 times 3. And we can check this. Times 3 is 9, times 2 is 18, times 2 is us 36. So now we can go ahead and see that the greatest common factor that they have is, well, this has all 2's and this is a 2. So my GCF is 2. Actually, 2, there's more pairs, right? So we have 2 2's here, and 2 of them here. So actually, in reality, my GCF is not 2. It's actually 2 by 2. So I have 2 by 2, and 2 times 2 is going to give us 4. So in reality, I missed a 2 here. The GCF of 8 and 36 is not 2, but it's actually 4. And then I can double check. There's another 2 here, but it's not. There's not another one down here. There's a pair of 3s here, but there isn't one up here. So the GCF is actually 4. Now we're going to go ahead and do the same things with these, and then the same thing with 3 numbers over here. All right, so this is what I just did. To find the GCF, you can use prime factorization, which is what I did in the other one. And so find the GCF of 12 and 56. So here's the factor tree of 12. Here's the factor tree of 56. We listed out the factors. And you don't want to make the same mistake that I did, where I only pulled out 1. But here's a pair, it's 2. And here's another pair of 2s. So 2 times 2 is 4. All right, so just be careful. Don't make the same mistake I did. Then here's some more practice problems that you can go ahead and try. I'm actually going to show you what I usually don't talk about until after we deal with LCM. But I'm going to show you something that is called the ladder method, which you can find, or you can use to find the LCM, which stands for least common multiple, and the greatest common factor. So right now we're only dealing with the greatest common factor, but I'm going to go ahead and show you how you can use that to find both. So I'm going to start off with the smallest prime number that goes into both 20 and 45. And I mean, 1 does, but we can go higher. Let's see, 2 goes into 20, but not 45. 3, no. 4, no. 5 does. All right, so let's go ahead and do 5. Now, 20 divided by 5, or 5 times something, is going to give me 20. That's actually going to be a 4. So I'm going to put a 4 down here. 5 times 4 gives us 20. 5 times 9 is going to give us the 45. So I'm going to go ahead and put a 9 here. And now these two numbers are relatively prime because they have no factors that, right? They have no factors in common. So I'm going to go ahead and make another L here. And this number coming straight down. So I'm going to go ahead and actually close this right here. This number in this section is my greatest common factor. So the greatest common factor of these two is actually 5. If I was finding that the least common multiple, the LCM, I would actually done 5 multiplied by 4 multiplied by 9. And that's how you would find the LCM, right? This is kind of like an L, which you can think of it as representing the L in LCM. So 5 times 4 times 9 would give you the LCM, but we're not talking about that until the next chapter. Let's go ahead and try one more. Let's do 32 and 90. Now this one has 3 numbers. This ladder method I'm showing you will not work for 3 numbers. So you can do prime factorization. The objective of this lesson was just to find it for 2 numbers. But if you want a challenge, you can go ahead and try it with 3, finding the LCM of 3 numbers, or sorry, the GCF of 3 numbers. All right, so let's see. They're both even, so I know they're divisible by 2. This would give me 16 over here, whereas this would give me 45. I can try this again and see if there's anything else that these two have in common. So they're not even, so 2 doesn't go into them. 3, no. 4 goes into this, but not this over here. 5, no. 6, no. 7, 8, 9 goes into 45. 10, no. 11, and it looks like we don't find anything. All right, so these two are relatively prime to each other. So that means my GCF is just going to be the 2 over here. All right, this is my GCF. Okay, let's keep going. Now, this is just an example you can go ahead and look at. Again, it says finding 2 numbers with a given GCF. Which pair of numbers has a GCF of 15? So then it gives you these each 4 different pairs, and you have to try to find out which one has a GCF of 15. Go ahead and read it. I'm not going to go over it, but this gives you an explanation as to why you can eliminate A right away, why you can eliminate C right away, and your only 2 choices would be B and D. And you list out the factors to find out which one has a GCF of 15. And lastly, I have a modeling real life problem. It says you are filling piñatas for your friend's birthday party. The list shows the gifts you are putting into the piñatas. You want identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas you can make? So you have these candies. Essentially, we want to find the greatest common factor of these 3 numbers to see, which one you can go ahead, how many you can make at most. So we list out the prime factorizations of them. We see that they'll have a 2 in common, they'll have a 3 in common, and that's it, because this has a 3, but none of the others do. This has 2 2s, but none of the others do, and 7 isn't anywhere else either. So I'll have 2 times 3 to give me 6. So at the most, they can make 6 piñatas. That's it for this lesson. If you have any questions, go ahead and let me know.